6.5 is going to bring us to the end of Unit 6. And the only difference between 6.5 and 6.4 is now we're going to center. The centers are all going to be at 0, 0. So a few things I need to remind you. First and foremost, I know it's an enlargement when the scale factor is greater than 1. I know it's a reduction when the scale factor is less than 1. And so if you ever get confused, just figure out, is the scale factor bigger than 1 or less than 1? Then you'll know if it's an enlargement or a reduction. How they're going to try to trick you is they might throw in something like 5 over 7 as a scale factor. Is that less than 1 or is that greater than 1? Less. So then it's a reduction. But if they throw 7 over 5, is that less than 1 or greater than 1? Then this is an enlargement. If they throw in some fractions, don't freak out about it. Just know if it's less than 1, it's a reduction. If it's greater than 1, it's an enlargement. Now, what they're going to do also is they're going to throw in those fractions in your problems, which is going to try to confuse some of you. If you know how we did this in 6.4, it's the same exact thing. We're going to start the origin. We're going to count the spaces horizontally and vertically, and we multiply those by the scale factor. And then we're going to plot images. So everything we do is going to be just like that. Everything else I have are examples. You have the worksheet in front of you. So number 2 is a dilation of 0.5. That's a reduction. It says in the directions, determine if the dilation is a reduction or enlargement. This is a reduction. So the first thing we do is answer the question. Then it says graph the image of the figure using that dilation given. Now that we know that it's a reduction, this is 0, 0. This is my center. I have to count the distance from the center to each vertex. So I'm going to start with H. It's 1 unit to the left, 1 unit horizontal. And I need to dilate it by a half. Meaning, instead of going over 2 here, 1 full space, I need half of that. H prime is going to be right here. You just take half the distance. And you'll do the same thing, except for Q and for U, you're going to have to do that with horizontal and vertical distances. For example, to Q, I have to go to the right 2 and up 2. Well, what would half of that be? What's half of to the right 2 and half of up 2? 1, 1. Q prime should be right here. You're going to have to multiply these distances in your head and either do it mental math or with a calculator. Same thing with the U. I go to the right 2, down 1. Half of that would be to the right 1, down a half. Where is that? That's U prime right there. And then you connect your dots. When you get your shape, it should be half of the size it was originally. It may or may not be really close to a side. It just depends where the center, where the origin is compared to where the shape is. Just so, if you go, how come it's really far away from this side and really close to this side? It's because the center, the origin, is way more on the left side of the figure, so everything else gets bumped over as well. Keep that in mind. I hope that makes sense to you. I then chose number 3 because number 3 has a dilation of 3 over 2. And some of you may not be used to multiplying things by 3 over 2, so let's do that as an example. First and foremost, enlargement or reduction. If you know, say it out loud.
Enlargement.
I agree. I usually will put a dot where 0, 0. Oops, that's not the dot. That's the dot. Just because on this worksheet, sometimes I can't see it, so I have to go where the Y is and trace it down and where the X is and trace it over, just so I know where I'm counting from. Now, if you're trying to find a distance of 3 over 2, if you go to the right 2 units and you need to multiply that by 3 over 2, sometimes it's easier to do this as a fraction. 2 times 3 over 2 means instead we're now going to go to the right by 3 units. See how that works? Instead of 2 units times 3 over 2, it's going to be 3 units. Or instead of 1 unit, we're going to go 3 halves or 1.5 units. So I'm going to go to the right 3 and up 1.5. My new G prime should be right here. That was the hardest part. So let me say it again. Instead of to the right 2 up 1, I go to the right 2, but I multiply that by 1.5, and I get 3. If you want to do this as a decimal, use your calculator. 2 times 1.5 is 3. And instead of up 1, I multiply that by 1.5. I go up 3. So I go to the right 3 and up 1.5. That's where I get G prime. I have to do that for every vertice. So now I'm going to go check this one out. To the left 1, up 3. So I need to multiply that by 1.5 and that by 1.5. So now I'm going to go left 1.5 and up 4.5 from the origin. Left 1.5, up 4.5. 1, 2, 3, 4.5. Sometimes your letters will be in the middle of a space because of the decimals, because of the fractions. So if I'm going left 1.5, I go 1.5. And then from the 1.5, I have to go up 4. Let me just make sure I'm writing that down. 1.5, and this is 4.5. And then up 1, 2, 3, 4 wholes and a half would be right there. Oh, and that should be P prime, Mr. Paramo. Thank you. Now I'm going to do the same thing for B. Down 1, 2, to the left 2, down 2, left 2. Multiply that by 1.5. And what you'll get is down 3, left 3. Use my ruler. Just want to look at it because when you're doing all that calculation, sometimes you look at it and you're like, did it get enlarged? Is it 3 halves bigger? Is it 1.5 times bigger than what it was? Does it look like an enlargement? Yeah, it does. But it's a little closer to this side. It doesn't matter because the center is really close to this bottom side and not the other sides. So the enlargement will be that much closer to those sides. I'm hoping that makes sense to you. So if you get stuck, do the fractions and the decimals off to the side like I just did. I have 3 more examples, but not like what we just did. I want to switch the other examples. Number 6 asks you for a rule. They're asking you, what happened from this blue shape from the black shape? Your rule is always going to be talking about what happened to these x's and y's. So the first thing you should always have is what happened to your x and y. That's the first thing you write. This was a dilation. These have the primes. These are the image. This got stretched. It was an enlargement. So something happened to the x and something happened to the y. And if this is a dilation, then the same thing happened to each x and to each y. Here's what I do. I take the image. I pick a letter. Let's pick the letter A. I go image first. I went up 1.5. I'm going to go to A prime. 1, 2, 3. I went up 1.5. I went over 3. Now I'm going to see what I did to go to A. I went up 1 and over 2. All I have to do is compare either the vertical or the horizontal or both. I'm going to compare the horizontal. Image compares to pre-image. Or I do the vertical. 1.5 compares to 1. I want to see, is that the same thing as each other? It should be. 1.5 compares to 1, or divided by 1. My calculator says it's 3 over 2. Look at that. They're the same. You go up by 3 over 2. You go over by 3 over 2. That's the same thing that happens with D. I can count over. 1, 2, 3, 4. I went over 4 units. Oh, 4.5 units. And up 3 units. I go over 3 units and up 2 units. And if you compare the image over the original, it's 3 over 2. So what does that tell you? You're dilating it by 3 over 2x to your x's and 3 over 2 to your y's. This is your scale factor multiplying every x, and this is your scale factor multiplying every single y. I could check the other points, but it's going to work either way.
So are they always going to be the same?
They have to be, otherwise it would not be in the same proportion. The last 2 examples I've picked were numbers 8 and number 12, just because we hadn't done anything like it before. So let's look at number 8 first. Determine if the scale factor will reduce or enlarge the figure. If it has a dilation of 2, will it reduce or enlarge? That's our first answer for 8. Find the coordinates of the vertices after the given dilation. If we dilate it by 2, and the point W was at -2, -1, and you multiply by 2, guess where W prime is going to be? It's 2 times that, -4, 2 times that, -2. That's all you have to do. It's going to double the distance away from 0, 0. We could do that same thing for E. E will now be at E prime will be at -4, 2. J prime will be at, guess, you tell me now, what's J prime going to be at?
4, 2.
You're right. You look at X, X is at 2, 0, so X prime must be at 4, 4, 0. There we go. Last example. Now they're going to ask you about this rule stuff again, and they gave you coordinates. They give you an example. Let's ignore that example. Let's go right to 12. It says S is at -4, -1. S prime's at -12, -3. A is at -3, 4. A prime is at -9, 3. Can you see a pattern of what they did to your x's and what they did to your y's? What'd they do? How'd they get these numbers? What are they doing to your x's? What are they doing to your y's? They're multiplying everything by 3. They're multiplying 3 times your x and 3 times your y. It's because the scale factor is 3. Times by 3, 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 you still get 0, times by 3, you multiply each one by 3, that's your rule. I'm going to stop your notes right there.